Alright, so here's how to do the cost of capital model. So, use the following information. Q equals L to the 1/4, K to the 3/4. That's our production function. Price at home is 2. Price overseas is P star, and that's 4. 16 units of labor at home, 1 unit of capital overseas, and then you've got 2 units of capital to play with. So how do you solve this thing? Well, the first thing you want to do is you want to use the equation that the marginal value of capital at home equals that overseas. So that's going to give you the profit maximizing allocation of capital. What is the marginal value of capital? Well, it's the price of output times how much output pops out for every unit of capital you put to work at home. So the marginal value of capital at home equals the marginal value of capital overseas. So how do we actually solve this? Well, let's use our production function, take the partial derivative with respect to capital. That is the marginal product of capital. So price times MPK at home equals price times MPK overseas. Okay, oops, there we are. So price times the marginal product of capital at home. So take the derivative with respect to capital. 3/4 drops down, subtract 1 from the exponent on capital. So price times 3/4 L to the 1/4 K to the minus 1/4. So 3/4 minus 1 is negative 1/4. Overseas, P star times 3/4 L star to the 1/4 power, K star to the negative 1/4. Okay, so we can go ahead and start plugging in all our various numbers into that. So the price at home is 2. 3/4 L at home is 16. 16 to the 1/4 power. K to the minus 1/4 is equal to P star is 4. 3/4 L star to the 1/4 power. Oops, L star is 1, so we just plug 1 in there. K star to the negative 1/4 power. So that is our key equation with all of our various variables plugged in. So 3/4 cancels with 3/4. So that's 2. 16 to the 1/4 is 2. K to the minus 1/4 is equal to 4. K star to the minus 1/4. 2 times 2 is 4. That cancels with that 4. What we're left with is K to the negative 1/4 equals K star to the negative 1/4. So how do you deal with a negative exponent? That's just a fraction. So this is equal to 1 over K to the 1/4. This is equal to 1 over K star to the 1/4. Cross multiply, K star to the 1/4 equals K to the 1/4. Take each side to the 4 power, quad it, whatever. K star equals K. So now we know that the optimal mix is going to be splitting our capital so that the amount of capital used overseas is the same as at home. How much capital do we have to play with in total? 2. That's the second key equation. So K plus, substitute from this equation into that K plus K star. K plus K equals 2. That tells us that the amount of capital we use at home is equal to 1. And the amount of capital used overseas is equal to 1 because K equals K star. So now we know the optimal split of capital. Finally, we can talk about how much output gets made in each country. Q, the amount of output at home, is L to the 1/4. So that's 16 to the 1/4 power times K, which is 1 to the 3/4 power. 16 to the 1/4 power is 2. 1 to the 3/4 power is 1, so that's just 2. Q star is 1 to the 1/4, 1 to the 3/4, or 1. And now if I ask you for profits, what do we have? It's price times quantity plus price star times quantity star. So price at home is 2, got that back up there, times quantity at home is 2, just calculated that. Price overseas is 4, calculated that up there. Quantity at home is, overseas rather, is 1, just calculated that. 4 plus 4 is a grand total of 8, and that is the level of profits. It's not always going to be the case that capital equals capital overseas. It's not always going to equal the case that revenues at home equal revenue overseas. That's just luck of the draw in this example. But that is the process. Good luck.